So in today's video, we'll be looking at what do you call this? The exponential expression. So in this case, just like the prior video, we looked at the division and the multiplication. So in this one, we'll be looking at addition and subtraction. Okay. So now, just like the one that we did prior, right? We had some rules or things to follow when we needed to simplify or calculate, right? So this one too, there's a few things that one should know, like for instance, rather let's look at them, right? So number one, it's basically the difference between or rather 2 squared, right? The difference of 2 squared. Let's say you have a squared minus b squared, right? So a squared minus b squared, that's the difference between 2 squared, which will give us a minus b and a plus b, right? So this is the first thing that one should understand before doing the simplification. So if you know this, you'll be able to do some activities, right? Okay, let's look at another one. 2, right? The second one, there's a difference between 2 cubes, right? So a3 minus b3, which should give us a minus b, and then a squared, basically square this, and then plus ab, and then plus b squared, right? So if you don't know how to do this, please comment down below so that I will make sure to do these examples, right? Or to do more examples on factorization. But by now I'm hoping that everyone know how to factorize difference between 2 squared and the difference between cubes and the sum of cubes. Sorry about that. So if you haven't, or rather you don't know how, this is how you should do it. Okay, so the first step, you will be given a cubed, let's say minus b cubed. Okay, so the first thing that you need, rather this bracket here, what I'm gonna do is gonna cube root these two values here. So you're gonna cube root a, then you're also gonna cube root b, right? You're gonna cube root these numbers here. So when you cube root a cubed, you get a, right? You get a, and then when you cube root b cubed, you get b. Okay, so now when it comes to okay, let us first look at the big bracket first, and then you're gonna square root the a. So rather not square root, but square the a. So you're gonna say a squared, so that number squared, and then after that you're gonna square root the b, or rather square the b, and then you're gonna say b squared, and then you're gonna multiply the two numbers there, and hence you'll get a times b, which is ab. Okay, ab. Now when it comes to signs, please take note of this acronym here, SOAP, also known as the SOAP method, right? So the S standing for same, right? The O standing for the opposite, and then the AP standing for always positive. Okay, so always positive, okay, so always positive. Okay, here same, so meaning we're taking the same sign, negative, opposite this negative becomes positive b, and then always positive, and hence this one will always be positive. Okay, so please take note of that. Similarly with the sum, or rather the sum of cubes, right? The sum of cubes, you do the same thing. You use the SOAP method, right? Let's look at an example of that. Let's say I have 2 cubed minus 3 cubed, right? So we know 2 cubed, that's 8, and then this is cube, right? And then 3 cubed, that's 27, and then you're gonna subtract, so you get this is 18. Well, this is 8 minus 27. Well, that's let's see, that's negative, that's 1 8 18. Okay, so you get 18. Please correct me there if I'm wrong, but if you want to factorize this, remember we said, okay, you're gonna cube root the 2, so meaning the cube root of 2, that will give us 2, hence you write 2 here. The cube root of 27, that's 3, and then the big bracket, then you're gonna square 2, and it will be 2 squared, and then square the 3 here, which is 3 squared, and then you times these two numbers here, which is 2 times 6, I mean 2 times 3. Okay, so now what we do is you use the SOAP method, so meaning same, it's a negative, and then opposite is positive, and then the or is positive in that case. Okay, let's calculate. So 3 minus 2, that's negative 1, times, well, that's 4, and then plus 6, and then plus 3 squared, that's 9, that's 9. Okay, negative 4, oh, the answer should be 19. It should be 19, right? 8 minus yeah, that's 19. Yeah, please double check on that. It is 19, right? Yeah. Okay, so that's negative 1 times 4 plus 6, what am I doing? Okay, okay, so 4 plus 6, that's 10, and then 10, 4 plus 6, that's 10, 10 plus 9, that's 19, so we get 19. So that is how we do the sum and the difference of cubes, right? So make sure that you note that on your notes, right? So we have a cube plus b cube. So this one should be remember s always the same, so meaning positive, b, and then you square a, opposite that's negative, then a times b, that's ab, and then always positive b squared. Okay, so that's another NB that one should note. And then number 4 is basically the common factor. Let's say I have ax plus bx. Well, this one, just take out the x outside, and then inside we'll have a plus b, right? As simple as that. So these are the things, out of the four NPs that one should note, right? So by now I'm thinking that everyone is already on par with these. Everyone know the difference between 2 squared, difference and sum of 3 cube, and then of cubes, and then of course the common factor, right? Now let's jump into it. Let's look at let's look at some examples here. Okay, let's say you have 3x plus 1, 3x plus 1 plus 3x, and then plus 3x minus 1, all divided by 3x plus 2 plus 3x plus 3x plus 1. Go on and solve this, or rather simplify this completely, right? Simplify this completely. You can pause the video if you wish. So let's go on and simplify this. Okay, so first of all, you notice that 3x and 3x is common in all these three terms here on the numerator, so meaning my 3x in that case will be my common factor. So I'll take out 3x, and hence inside I'll have 3, and then 1, and then plus 1, and then plus 3 negative 1. Okay, all divided by here again I notice we have the same thing here, 3x, 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 and hence the 3x is common, and hence at the bottom I'll have 3 squared plus 1 plus 3 1. Okay, I hope that makes sense. So what we did basically is we did the common factor. What happened? Okay, so we did the common factor here, which is this part here, number 4. We took out the common number, rather something that is common in all these three, and then you take it outside, right, and write whatever is left. So you can see that we took out 3x here, so meaning what I'm left with is 3 1, so it is 3 and 1 here, because we know that 3x times 3 1, if I take out this one, will give us 3x plus 1, and then is the same as that. So if I take out this, then I'm left with that, right? Here similarly I have 3x, I only have 3x times 1, right? 3x times 1 is the same as 3x. So if I take out 3x, I'm left with what? With 1, right? Similarly with this one here, I have 3x minus 1, which is the same as 3x times 3 negative 1. Remember our rules and properties of exponent. Whenever you multiply the same bases, you add, and hence why it will result in that. Okay, so if I take out 3x here, I'm left with 3 negative 1 in that case. So I hope that makes sense. Here I'm left with 3 1. I hope that makes sense, right? And then after that you can see that this here is common with that, so I can remove it. Now don't just remove. Now in this case I can see that I have two terms. I have 3x, then I have this whole term here inside, then here I have 3x, and then I have this whole term here inside. So now I'm dealing with multiplication. That means that now I can cross multiply this, right? I can cross multiply, or rather I can cross cancel the 3x, right? I can cross cancel the 3x. Okay, so now it becomes simple. I can just plug this on my calculator. So I have 3 4 plus 1 over 3, okay, all divided by 9 10 13, right? Okay, I have 13. So here on top I should have well, that's 4 12 over 3. That's the common difference is 12, and then plus 1 divided by 3, so meaning I should have 13 over 3 times 1 over 13, hence my final answer will give me 1 over 3. You can simply plug this on a calculator, and then you will get exactly the same answer, 1 over 3. Okay, let me double check this. Let me just double check. So 3 squared, and then plus 1 plus 3, and then plus 3 negative 1. Oh, hold on. Oh no, plus 1. Okay, plus 1. Yes, you get 1 over 3, and you get a final answer of 1 over 3. Okay, so this is simple, right? This is simple. So let's look at example number 2. Example number 2. Okay, so example number 2. Please pause the video and try this on your own. If you have x squared minus 4x minus 5, all divided by square root of x minus 5, right? So please try this on your own and see what you get. So here, right, so here we notice that this here is a quadratic equation, this here is a quadratic equation, so that means that I can simplify. Remember that here the question would be simplified completely, right? You're not solving anything, you just, rather you are solving, but you are simplifying completely. So meaning if here you see that, okay, here like there's nothing I can really do here, there's nothing I can really do, or rather we notice that, okay, so the question would be simplified further, right? And you say, yeah, this one here, it can't be simplified, right? So now note, when they say simplify further, they want you to break something in pieces and make it make it as smaller as possible, right? You want to make something smaller as possible, right? You're not solving anything, you're not solving for x, you're not solving for anything, you're making something smaller. So meaning in this case here, this, they want it to be smaller, meaning there is something that we have to do in order for us to make this smaller. So in this case, I noticed that, okay, the numerator, there's nothing I can do with the numerator, meaning that, okay, I have to do something with the denominator. Now in that case, I have to factorize the denominator. Let us see. So if I factorize, so I'll have x, and then I have x here, and then the 5 and 1, and then negative and positive, right? And then of course here at the bottom I'll have x minus 5. So this is the same as the square root of x minus 5 times the square root of x plus 1, all divided by the square root of x minus 5, right? So here in this case, I can see that these two here are the same, meaning I can cross cancel them, and then hence my final answer will be x plus 1, right? So and then you can prove whether your answer is the same as that one by letting x be equal to any number except a number that will make this a math that will give you a math error, of course. So x can be any number except a number that will give you a math error. So you can say x is equal to 2, or rather x is equal to 3. So if I have x is equal to 3, that won't work, right? Because here I will have a x value, or rather an x value that I'll have a negative number, right? So let us x can be any value in that case, but it cannot be a number that will give you a math error. So first double check your x value here. If it works, then if it works, then that number will definitely work here in this case here, right? So make sure that here, x plus 1, x plus 5, this is 1. Okay, so that will mean that x squared minus 4x minus 5 all divided by root x minus 5 is equal to x plus 1. Now let us note something. So we look at the denominator, so meaning the denominator in that case, we notice that x minus 5, it should be greater than 0, so meaning x should be a number greater than 5, right? X should be a number greater than 5. Okay, that makes sense. And x cannot in that case be equal to 5, and it can also not be equal to negative 1, right? Cannot be negative 1. Why? Because if it's negative 1, or it can be negative 1, but it cannot be 5. It cannot be negative 1. Well, it cannot be negative, so we exclude the negative, so meaning x has to be greater than 5, and do not include the 5 as well, right? Do not include the 5. So meaning x can be any value, so I can plug in any value here that I wish to plug, but my x value should be greater than 5, right? So let us see. So let us say x is equal to 8, right? So then 8 plus 1, that's 9, which would give me 3. So meaning here I should also have the same value. I should also get a value of 3 when I do that. 8 minus 5, that's 3. Okay, so let us see. So 8 squared minus 4 times 8, and then minus 5, all divided by root 3. I get a value of 3, so meaning my answer is correct. Okay, so please double check that my x value should be greater than 5. Okay, next. And another thing, to check whether you can simplify something further, you should be, when like you plug in an x value, you should get something like this in this form here, 0 over 0. That means that something is simplifiable, or you can simplify it further. So this is what we call an interdeterminant form, right? It's called the interdeterminant form, so meaning that it can be simplified further. Let's say, for instance, what will make the bottom part equal to 0? Well, it will be 5, right? Because we have 5 minus 5, which is equal to square root 0, which is equal to 0. Now if you take that same 5 and plug it in on the numerator, well, you will get 5 squared minus 5 times 4, and then minus 5, right? This one will give us something like 25 minus 20 minus 5. Well, this one gives us 0, so meaning we do get 0 over 0. So meaning in that case we can simplify it. Right? So make sure that you note that that one there. So meaning my final answer in that case will be x plus 1. Okay, let us look at number 3. Let's look at the last one here. Let's say you have x raised to the power 2n minus x raised to the power n, and then minus 12, all divided by xn plus 3. Okay, so pause the video to do this one here, and then check your answer when you're done, right? Okay, so with this one here, you notice something. You notice that, okay, here if I let xn equal to k, then on my numerator I have a quadratic equation, right? I have a quadratic equation, right? And then here at the bottom I have k plus 3. Okay, so now the next thing to do is, of course, whenever you have a quadratic equation, make sure that you factorize the quadratic equation. So in this case I'll have k and k, and then 4 and 3, because 4 times 3, that's 12, and then I have negative positive, and here at the bottom I have k plus 3, and hence k plus 3 and k plus 3 will move, and hence my final answer in that case will be k minus 4, right? But that's not my final answer, because we said k is equal to 4, k is equal to xn, so meaning my final answer will be n minus 4, right? So that's the final answer there, right? So simple as that. Please try more and more questions when dealing with exponentials. yeah, this is it for this video here. I'm gonna stop there, and then on our next video we'll be looking at the graphs, how to plot the graphs, how to calculate the intercepts, and translations, the translations of the graph, so, and the domain and range, of course. But for this video we are done here. I hope that you find something on this video here, and yeah, I'll catch you on another one. Cool.